3-5, Equations, Tables, and Graphs. This lesson is all about the relationship between equations, tables, and graphs. Every time you have an equation, you can make a table and a graph to go with it. Every time you have a graph, you can find the equation that goes with it and make a table that goes with it. And every time you have a table, you can find the equation that goes with the table and you can graph it. So these three things are related. This lesson is all about giving you one part and you finding the other two parts. So let's start. One important thing to notice. We use X and Y a lot, and we use X and Y when we're graphing. But sometimes in word problems, you will see something that looks like this or like this with some different variables. What you need to know is if the variable is in the Y position, it means Y. And if the variable is in the X position, it means X. So if you did not have this first equation, if this was not here and you just had this, you would say, oh, this is Y, this is X. So that way you know how to do your table. So your table would have an S and an R instead of an X and a Y. And on this one, your table would have an A and a B. But it still means the same thing, just different variables. Okay, let's start with an equation and find the other two things, which would be a table and a graph. Well, that's easy. All of you could do the table for this. If X is -2, what's Y? -6, because 3 times -2 is -6. If X is -1, what's Y? -3. If X is 0, Y is 0. If X is 1, Y is 3. And I'll have to scoot over because I didn't leave myself enough room. If X is 2, then Y is 6. So now you have a table with 5 ordered pairs, and you chose your X's by sticking close to 0. There's the first step. You have a table. Now, could you graph that? Certainly. So take out some graph paper and graph this equation. Well, -2, 6, -2, -6 I should say, -1, -3, 0, 0, 1, 3, and 2, 6. When you graph that on graph paper, you're going to get a line that looks much better than mine. Connect all your dots, put arrows on the end of your line, and you've just done it. You've taken one of the three parts and you found the other parts. Now, something else to notice. Sometimes the book will write an input-output table sideways. So, when it does that, if that bothers you, because I really don't like it that way myself personally, I just switch it around when I write it and make sure that my X's are all in the right spot and my Y's are in the right spot, because it makes more logical sense to me sideways. So sometimes you might have to switch around a table that the book wrote sideways. Okay, now let's start with the table. Here's our input-output table. We have to make the other two parts, the graph and find the equation. Now, of course, that's easy to graph. Finding the equation is the most difficult part. So what you do is you look for a pattern. You look at the X values and you look at the Y values and you see if you see any particular pattern between X and Y. So as I'm noticing and looking, I'm thinking, oh, it looks like the Y values are always 3 more than the X values. So they must be adding 3. So I'm going to always start by writing my equation by putting Y equals. Then I'm going to probably, on this one, try X plus 3, because that looks like it's right. Now I have to try and see if it really works. So if I put 0 in, I get 3. If I put 2 in, I get 5. If I put 5 in, I get 8. 9, I get 12. 12, I get 15. So that actually works. Sometimes it's hard to find the equation. This one was a really easy one to find. But sometimes it's hard. Now, of course, any of us could graph it. That's easy. Okay, now this graph is going to not be very great with no graph paper, but on graph paper, this graph would be absolutely splendid. So, the first point would be 0, 3, and then you would have 2, 5, and then you would have 5, 8, and 9, 12, and my last point is off my screen. But if you graphed it on graph paper, it would be lovely, it would be a line, and you would be done because you started with the part they gave you, this part, started with the part they gave you, and you found the equation and the graph, the other two parts. There's always 3 parts. They always give you 1 part, and you have to find the other 2. Now this time they're giving us a graph, and we have to come up with a table and an equation. So whenever you get a graph and you have to come up with a table, you want to look for exact points that you can clearly identify that are on one of the crisscross marks. So in other words, you wouldn't want a point that was here because it would be in between marks. You would want points that were for sure here, 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 any of these points. So you just go through and choose some points. So let me choose some points. Let's choose this point and this point, because they're on crisscross marks, and we'll make a table. So what are the addresses of those points? Well, the first point we chose is at -2, 0. So you put that in. The second point we chose is at 0, 2. And the third point we chose is at 2, 4. Now we made a table. So we just did the first part, we made the table. Now we have to come up with an equation. Sometimes if you only have 3 points, it's harder to come up with an equation, and sometimes not. But remember, we're looking for a pattern because we want to have y equals some x plus something, or y equals some x minus something, or y equals 3x or 2x. So we're looking for a pattern from the x's to the y's. So, does anybody see anything that's a pattern from x to y? Well, it looks to me like the y's are all 2 bigger than the x's. See, because if I went -2 plus 2, I would get 0. 0 plus 2, 2. 2 plus 2, 4. So it must be that my equation is x plus 2. So I have to try it out and make sure. -2 plus 2, 0. 0 plus 2, 2. 2 plus 2, 4. So there's our equation. We started with the graph. We found the equation in the table. Extra credit, identify the speaker that you hear.
Yes. So many names and an IH.
Well, it's just one of those language things.